Translation is a classic problem in computer science. How do you translate a sentence from one human language into another? This seems like a problem that computers are well suited to solve. Languages follow well-defined rules, and we have lots of sample data to train our machine learning models. And yet, the problem has not been solved, largely because languages don't always follow rules. We have idioms, we have subtle contextual clues that make it hard to provide a computer with hard and fast rules for translation. Unbabel is a company whose solution to translation puts a human in the loop to correct the error-prone translations that computers often make. In this episode, Vasco Pedro joins the show to explain Unbabel's machine learning-driven approach to translation, its technology stack, and the business applications for translation. And also, so a lot of interesting nuggets about how human language works and why it makes a lot of sense to put a human in the loop. And also, how do you allocate tasks to those humans in the loop? You don't want to just allocate random language tasks to random humans. You actually want to give them tasks that they have a domain expertise in, aside from just having a language expertise. So I really enjoyed this episode about translation with Vasco Pedro. Saji is an end-to-end data platform that lets you focus on deriving business value from data. With Saji Present, you can turn your data into a story, easily sharing a presentation from your data lake. Explore data and drill down into details, creating rich visualizations. With Saji Manager, you can easily build data pipelines of jobs mixing Spark, R, Python, and more. Saji is great for predictive analytics, whether you're predicting the failure of a machine in your factory or predicting which sales leads will be the most valuable. Saji helps you take control of your wide variety of data sources and gets them in one place. Check it out at saji.com, SAAGIE.com. Thanks to Saji for being a sponsor of Software Engineering Daily. Vasco Pedro is the CEO of Unbabel. Vasco, welcome to Software Engineering Daily.
Thank you very much. It's a pleasure to be here.
The problem of translating between human languages is something that computer scientists have worked on for a long time. What is it about translation that makes it a problem that is both well-formed for computers to work on, but also very challenging to solve?
It's a great question. So translation, and machine translation in particular, was one of the original problems that kind of created the field of AI, right? So people in the beginning thought, hey, let's think of language as a cipher, and so use the same methods that we use to decipher messages. At the time, there's a lot of spy codes and a lot of work on that. And I'm sure in like 5 years, we'll have something that can translate perfectly, right? And this was in the 60s. And language has always been elusive, right? Because it's always been like 5 to 10 years away. We're almost there. And I think that the main reason is because language is probably the most obvious expression of our intelligence. It's something that it really uses a lot of our brain capacity. It has, it enables to express everything from classification to abstraction to reasoning. It can be meta. You have nuance. You have comedy and a lot of other aspects. And so it just makes it really hard to decode in a way that you can then do an efficient machine translation. And so there's been a lot of work since then. I mean, in the 90s, there was a breakthrough with statistical models. Recently, in the last 3 years, there was another breakthrough with neural models. And every time we think, oh, now we get it, right? But we're so adept as humans of detecting flaws in language because we interact with it so much that it's very easy for machine translation to fail and very hard to get all the cultural nuances, references correct.
Unbabel is building a multilingual understanding between companies and their customers. Can you give a high-level explanation for how Unbabel works?
Sure. So That's a great description of Unbabel, by the way.
It's on your website.
Yeah. But I love the way you said it. It's very, I almost want to get the recording play out. Here's what we do. It's really well said. The way it works basically is, we try to create a hybrid system. So think about humans and machines creating a new type of machine, right? So humans and technology create this hybrid machine, and we're fundamentally, in a way, creating the operating system for this machine focused on language. And so we fundamentally believe that it really takes a combination of technology and humans to produce the quality, speed, and scale that we're looking for. The system at its base, the way it works is text comes in. We first do machine translation. We then use quality estimation, which is another neural model that basically determines whether the output of the machine translation is good enough or if we need humans. Then we select from our crowd of 45,000 translators automatically who are the right translators to be translating that content and revising it. They do that in sequence, so you'd have one person checking the output of the machine translation, and then a second person checking the output of the first person. And then at the end, it gets sent back to the customer, or it gets returned depending if you use the API or if you use an integration. And the system learns from this output. So there's a continuous learning process.
Now, the human in the loop, I can totally understand. You try to run the machine translation, and then you have the human in the loop check it, and then why do you have a second human in the loop check it after that?
Well, I mean, the definition of human error, human error is something that is very abundant on any human process. And humans correcting text typically is, like right now, that's kind of the state of the art of quality is you give it to a human and he does it. But it still produces a lot of errors. And so this is basically for redundancy, right? For having another pair of eyes to catch any mistakes you might have done.
So this is a supply and demand equation. How do you make sure that you have enough work for all of these translators to be translating, and also having enough humans such that if you get a spike in load, you can accommodate that spike in load? How do you manage that supply and demand equation between the translators and the load of work?
So it's a great question. I think it's one of the biggest issues, right? I mean, we're still in a phase where fortunately we have a lot of supply, and then we're really working on demand. And that's definitely one of the biggest factors that drives community engagement. One of the things that we do is we keep a fine balance between, the language pair. So we typically talk about language pairs, meaning, it's typically people translate from the Portuguese to English or English to Portuguese, or, English to another language, rather than it's not so much about language pairs. But we keep each language pair open for new translators only if we have enough volume that requires more people, right? So whenever there's increasing volume, we kind of open the language pair again, and then as we have enough people, we kind of now we're not taking more people. Initially, we actually let everybody in, and that created some frustration in the community because then that created a scarcity of tasks, and in the end, that creates unsatisfaction. And so we found that it's really about high curated individuals that then have enough tasks that they think their time is valuable being spent at Unbabel.
I find this language pairs question interesting. Why do you model things as, like translation from Spanish to English or Italian to French? Is it too hard to make like a universal substrate that all of the languages would translate to, and then you can translate from there to any language?
Well, basically, there's a question of cost. So, if we were, let's say we use English as an intermediate language, right? And you translate everything to English and then English to something. The problem is not only you'd be paying twice as much because by far the biggest cost of translation right now is the human component, but also there's always some loss of quality, right? So you'd have some loss of context or quality when you go to English, and then when you go from English to something else, you would probably result in slightly lower quality than if you went straight from Portuguese to French, for example. Also, sometimes it's easier to find in certain language pairs, just easier to find people that know directly that language pair, like Portuguese and Spanish. So if there's enough people for the direct language pair, then you don't really need to go through another language pair. Sometimes we do need to do that. So sometimes we'll go through English if a customer really needs that language pair that we don't. So we don't offer all language pairs. We offer right now about 60 something language pairs. But obviously there's much more. And so sometimes that is required.
Let's get into talking about the technology stack and eventually the machine learning pipeline. Can you just describe some of the technologies that Unbabel uses and maybe how a request for translation makes its way through that stack?
Sure, yeah. So the majority of our backend of our databases are in MongoDB. So I don't know if you want me to go at that deep level or if you want me to keep it a little bit lighter.
Sure, no, please.
Okay,
please.
Yeah. So majority of our databases are in MongoDB. We use Python throughout Unbabel. Pretty much everything is built on Python. We have, obviously in the front end we use, the usual stuff. We have apps on iPhone and Android, and so we try to do everything using sockets because so things are synchronous makes it easier. And then for machine learning, so for deep learning, we're using, I think we're using Torch right now. I think we tried TensorFlow and Theano, but I think we're using Torch right now for most of the stuff that we do. What else? We're using AWS, so all of our machines run on AWS pretty much, except for the deep learning stuff that we actually have a server in-house to train the models. And that was actually an interesting situation we are right now, where the stock machines that you get at AWS for deep learning have max 4 gigs of RAM. But a lot of the models that we train are bigger than that. So we actually needed to get like a big machine that would have each graphic card has 12 gigs of RAM. But I think next year we're going to start seeing suitable machines in the cloud for a value that would make sense again to use cloud machines. Right now it's a much better deal to buy your own, and train your models there. So a translation, the way it works is, so typically most of our customers, they send text through some integration. Let's say our most known integration right now, so is on the area of customer service. So the use case that we're exploring a lot is how do we enable within a company, as you put it, right? Within a company, the service part becoming multilingual. So if you have an agent that speaks English, you can just add our app, and basically that agent can support customers in any language, which basically means we're decoupling language from customer service. And this means that you can hire people independently of language, and you can hire people that are really good customer service agents, not just because they speak a language, but they actually know your product and they're the right person. It means you can also expand within, your own, your team without having to create teams in other countries to support those countries. And so typically what would happen is an agent would reply to a customer ticket in English, and that translation through our Zendesk integration, for example, or our Salesforce integration would then be sent to Unbabel. And so the backend so we have an app on each of those applications. The app basically has a backend that communicates with our API, sends the translation through the API. The API then puts it in the queue. First, it will do machine translation, so it uses our machine translation stack is built. The one in production right now is built on top of Moses. So, we're working now on Neural MT, which should be launched sometime this year. And then after that, the quality estimation is again a neural model that has been trained. So it makes an assertion of whether that translation has enough quality. If not, it will then be put on a queue for translators. Again, there's a lot of technology there that basically tries to define it. There's a queue system that would say, okay, which translators do I send this to? And then after that, a translator will pick it up and can do this on his desktop, browser, iPhone, Android. And he will actually be experiencing another part of our technology, which is what we call smart check technology, which is the goal is to help the translators while they're translating. So it gives a lot of hints, suggestions, identifies errors, things like that. It's like it's like word spell checker on steroids. It will tell you things like, oh, you're using formal tone, but the customer actually wants informal tone, and oh, there's a grammar error here, and so on. And then after that, after it's done with people, then it gets sent back through the API, back to the integration, back to Zen, in the case of Zendesk, for example, and gets posted as a reply in the language that the original user wants. So the experience for the user is completely seamless, right? I mean, what happens is, in a way, we're making translation disappear, right? The agent just writes in English, the user just gets it in whatever language they get it, and as far as they know, the other person speaks their language.
Continuous integration gives you faster, safer software delivery. With a continuous integration tool like Snap CI from ThoughtWorks, the members of your team can push changes independently of each other, and they can all see their new builds running against different phases of tests before those changes make their way into production. The fastest moving companies that I've talked to on Software Engineering Daily are all using continuous integration. Snap CI from ThoughtWorks is available to anyone. And if you go to snap.ci/software engineering daily, you can check it out for yourself and support Software Engineering Daily. With just a few clicks, I had my own continuous integration set up for some projects that were just sitting in my GitHub account without continuous integration. I got continuous integration up quite easily using Snap CI. If you want to be that hero at your company that starts moving your organization towards deploying often, more confidently, towards that DevOps dream, start working with Snap CI at snap.ci/software engineering daily. Your coworkers will see you working with Snap CI, and they will fall in love with it themselves. Oftentimes, it takes somebody at a bigger company to go out on their own and say, okay, I'm going to roll out CI even though nobody else at the company is using it. And maybe that hero at the company is going to be you. So check out snap.ci/software engineering daily. And thanks to ThoughtWorks for being a continued sponsor of Software Engineering Daily. It really means a lot. You mentioned this queuing process. When you have a request for a translation to be processed by a translator, you have some way of deciding which translator that request would go to. Now, if a request is getting translated from English to Spanish, what would be the different conditions for sending that request to different translator? Like, if you have this, 30 different translators that could translate it from English to Spanish, why does it matter which one you send the request to?
Well, what we see is this huge difference between, sending you something that you are actually an expert on versus something that you don't care, right? I mean, if I don't know if you're an expert in fishing, but if I send you, assuming you are, if I send an article about, how you fish in a particular situation, you do a much better job than someone that isn't, versus if I send you something in a topic you don't care. So that actually sending the right task to the right person really increases speed, accuracy, quality, reduces costs, has a lot of benefits. And also, more importantly, it makes you happier. I mean, it's really crappy to be translating something that you don't like, but reading something that is engaging and that you care about, it's actually rewarding, so it means you're also happier.
And that's a fascinating observation, because we're in this time where more and more work is becoming sort of mechanically outsourced, whether we're talking about mechanical Turk type of tasks, but you're creating an experience that is actually a little more pleasurable for the outsourced knowledge worker, because what you're saying is that it's better if the translator knows a little bit about the domain. Like if they're a fishing expert, then you should send them a translation blob about fishing, because then they'll enjoy translating it.
Exactly. That's exactly it. I mean, I think it's the happier our translators are, the better work they'll do, the more rewarding it is. Overall, it's a win-win situation. And so for us, it also means our customers are happier. There's a virtual cycle there. And then the idea, and we're still kind of early on this, but you actually have a lot of data that you can use to identify that. Not only, the rating of quality of tasks, but things like, which kind of task do they actually, if you offer them, do they take it, right? Because people can skip tasks if they don't want it. And so you can actually start creating a profile of, oh, here's what this person likes. And then you could even take it further and do, social network analysis and understand their interests and say, okay, well, this person did a master's degree in mechanical engineering. He probably knows about this stuff versus, wine. So there's a lot of information that can actually help create a profile that then makes it much more efficient to give you something you really enjoy.
Now, as I understand, the machine learning pipeline starts maybe when the translation finishes. So, for example, if a request to translate something comes in, it gets translated, it gets responded to, then the both the input and the output can be put into the supervised machine learning system. Is that accurate?
It is. I mean, machine learning, there's the learning part and there's the application of the machine learning, right? And so the application of the machine learning happens from the beginning, right? So when you're doing machine translation, you're actually using machine learning. You're using a trained model, right? But the training part with new data, we're actually doing it not instantaneously, but more on every few days. So every few days you lump the data and you retrain the engine.
Why do you batch it?
Well, because there's not a lot of efficient models right now that enable you to do online learning for machine learning. So there's a model out of Stanford, the Lilt guys that they call interactive MT, but also because we didn't see a lot of benefit. So we also have other stuff in there like translation memories and things like that. So that translation memories, for example, capture the very repetitive thing. So where it would help is, okay, I've used this sentence, I translate it, and then I get another sentence exactly like it, right? So I already know. That gets covered by simple technologies or simpler technologies like translation memories. The machine learning component is really the really big benefits you have is you have a statistically significant chunk of new data, and that's going to change the engine.
I did a show a while ago about something called the pancake stack, which is, we got kind of off topic in that episode, but that was just it was supposed to ostensibly be about online machine learning and getting these streaming workflows going, which turns out to be incredibly complicated. I don't know if you've heard of Pipeline IO, but I don't know if you're interested in it. Right, okay. So yeah, that was the guy who I was talking to, Chris Fregley. Can you talk more about that? What are the challenges of getting the online machine learning process going? And for listeners who don't know what that means, it's like you have new data and you're constantly feeding that data into the model and updating the model.
Yeah, so it's the updating the model part that is hard, right? Because you need to train. So for example, to give you a sense, every neural model that we have right now takes, I would say, a week to train, right? A week to 2 weeks. So the hard part is when in statistical models, you're basically calculating weight distributions, right? And so when you add new data, you need to figure out how that impacts the whole model. And that typically is done with retraining the model. But if you retrain from scratch, it's going to take you a few days. So you need to figure out a way that you can kind of add the new data and estimate the new weights in a really, really efficient way. And then, so what some people do is they have kind of a speedy way of doing this, but then a few days later, they will retrain the whole model.
Help me understand why people choose different machine learning frameworks. And maybe this is sounds like a naive question. You're using Torch. TensorFlow has all the popularity and attention right now. You mentioned Theano. How do these different machine learning frameworks differ? And does it even matter today which one you choose?
Yeah, not really. I mean, for us, I think initially was, a lot of times the way this happens is the person that starts working with is very comfortable with one of them. And so it just speeds up the process of doing it. Sometimes some of them actually support, let's say, new features on these graphic cards that just make it a little bit faster, or they have a Python SDK that makes it really easy. It's usually things like that. I think in the end, the basic kind of training a model, it doesn't make a lot of difference. I think it's more of the features, ease of use, and a lot of that is, it's a little like and I think this is becoming more and more, it's a little bit like the, VI versus Emacs discussion of which one is better.
I believe that. Although, so like I think about the React JS front end framework from Facebook, and this framework caught fire in part because it did some stuff right fundamentally from the beginning, but also I think because people felt like, oh, Facebook is putting a lot of energy into this.
I think Google is doing the same with TensorFlow, right? I mean, there's a lot of energy there, and so people are kind of picking it up, right? So I wouldn't be surprised. I mean, we've been experimenting and doing some stuff with all of them, and I wouldn't be surprised if 6 months to a year. And I think there's a little bit of a war going on of like a race of trying to become the dominant machine deep learning framework. And there's a lot of benefit for that, right? Because then you have people that really know your framework, and so you can recruit directly from there, and increase your popularity. And it's a little bit like Google ended up owning the mobile world with the Android OS, right? And if they can also own the deep learning world with their framework, it just increases their mind share, which is great for them.
And one thing I've heard recently, so I did a show with this robotics company that uses Google's managed machine learning, which I think is like TensorFlow. It's basically TensorFlow, but it's like managed TensorFlow, and I think it's just in beta right now. But it sounded like one of the big assets of the managed machine learning is that it really scales up and down as you need it to, and I guess the dynamic scaling is a significant challenge, or maybe you can tell me whether that's correct, or you can tell me what are the assets of. Okay,
definitely it is. So what we're seeing is the reason why we got right now we're running with Titan X graphic cards in house, and we got a new 1080. So the Titan X have 12 gigs of RAM, the 1080 has 8. And the reason why we needed that is because it's very hard to break the models into smaller chunks and train them. I mean, that's very complicated. It's much easier to actually have the whole model in one graphic card. And I've been hearing about, we haven't tried it yet, but I've been hearing about like the scalable managed machine learning data. And if indeed what they do is great, you want to speed up the training of your model, just add more machines, then that's fantastic, right? But at the time we looked at that and we said, okay, we're going to spend years, maybe a year just trying to get this right. It's not worth it. Let's just spend the money on a bigger graphic cards, and it fits in 12 gigs, so it's fine.
If Google gets that business right, that seems like a massive business. That seems like a massive intro into, they're obviously moving into the cloud more convincingly, and I think I've heard similar praise of the managed Kubernetes clustering. It seems like they're, Have you taken seriously the idea of moving some of your infrastructure to GCE?
We haven't, and I think it's mostly because, we're using the Google infrastructure for other services, language identification, we use in some languages, we use their machine translation in some languages, we don't have coverage for all languages, and so we definitely, and I think they do a fantastic job. But initially, their approach initially to the cloud was too managed. It was a little bit like, oh, give me the program, I'll just run it. You don't have to worry about anything, which is great in certain cases. But we started.
They were too early.
Yeah, we started with Heroku, which was great initially. We don't, you don't have to worry about infrastructure. But then at some point, we really needed to be a little more bare metal, or at least have more control over the individual infrastructure. And so we moved to AWS. And to be honest, I haven't really kept up on their infrastructure part on what's going on at Google. Once in a while I hear stuff and it looks really good, but we have to see it. There's also a little bit of once you have a method that kind of works for you, it's changing it takes a little bit more. It's always harder, right? And I think
of course,
right. And our A team now is super happy with the machine here, right? They're like, oh, this is great. They were actually talking about trying. There's also IBM also has a cloud that they're launching for the same purpose, and so we're always trying new things. But it's kind of you have something that it's easy. You don't want to waste more time figuring out how to change. This is good for now, and you just keep doing it, right? You just keep going because it speeds up your development process. I think if they do figure that out, like really manage scalable machine learning cloud, I think that's a huge business. There's a lot of there's a few companies at least developing hardware specifically for machine learning, new processors. I think we're seeing a lot of changes. I would, in the next couple of years, I think we're going to see a lot of very exciting new things out there. Because right now, especially this last year, when it comes to hardware and infrastructure for deep learning, it's still very much in the early days.
Yeah, I certainly like the TCU comes to mind. What is it? TPU, tensor processing unit.
Exactly.
That'll be a thing. But and I also I think I talked to somebody at Intel, or so who did I talk to? Some chip company who was talking about like how they're working on special chips for machine learning, and I was like, well, I wonder if, because I think Intel is trying to get into the cloud business, so I wonder if that could be a business like here's some chips on a cloud, and there are special Intel chips, and if you want to use them, you've got to go to the Intel cloud.
Could be. I mean, I've been talking also with some startups. Cerebra is one of the startups that they're developing this really exciting hardware for machine learning, which the promise is tremendous. They're still early, they're still testing in beta, but it's really like an order of magnitude faster than what we're seeing right now.
Now, so we were talking about the GCE services and how they're kind of moving up market and down market at the same time in terms of like the abstraction level. So the down market would be like the Kubernetes stuff, but the up market is how they are, they've got these services like you can just give it an image and it'll classify the image as an API request, or you give it a blob of text and it'll translate the text as an API request. So the translation, I imagine Google Translate is pretty good, but they don't have the robust pipeline of the human editing. So do you? And I think you mentioned since you don't have every language yet, sometimes you might kick it to Google Translate. Can you use Google Translate basically to bootstrap some of your language models, because you can, instead of just using the Unbabel model for the initial translation, you could just kick it to Google Translate and then send it to the human in the loop and then use the result to update your personal model?
Well, I mean, technically, sure, but we don't. So, I mean, Google is very, and correctly so, owns their models, and you can't use the output of their model to train another model because you're creating competition. And so we don't.
That's illegal.
Yeah, you can't do that. I mean, not legally, at least. And so we don't do it. We train our models based on publicly available data, and then once we launch them, then we start increasing them with our own data.
I see. Okay. I've got some kind of broader questions about translation because it's such an interesting topic.
Thank you. Yeah, I think so too.
So how does translating? Because I mean, most of the shows that I've done about anything relating to translation is like, how do you translate one programming language to another language? How does translating between human languages compare to translating between programming languages?
Well, it's incredibly more complex, right? Because programming languages have a defined grammar, and there's really no exceptions. And human languages are incredibly rich with exceptions and inventiveness and new words, and so there's no algorithmic way of doing it. That's why you need probabilistic methods. And you need machine learning and so on. And in fact, we don't even really understand what is the process that's going on inside someone's head when they're translating, right? And that's one of the issues, is that the way that I think about it is right now we're still in this pre-industrial revolution stage in translation where it's really a craft, and you have a lot of people and you're saying, hey, translate this, and you give a translation to someone. But if you think about it, the way that people created a shoe factory or a Ford automation factory, it wasn't by asking one person, okay, you build this car, and then you build that car, and then you build the other one, right? You reverse engineer the process of building a car, and then you create an assembly line. And we're trying to, in a way, do that to translation. We're trying to reverse engineer what's going on inside someone's brain to understand what's the process of translation, so that we understand which parts are really suitable for AI and which parts are really not suitable for AI and they really require humans. Because fundamentally, humans weren't really built to remember obscure meanings of particular pieces of a fishing rod in three languages, right? They're really good at understanding the nuance of communication, the appropriateness within the culture, like the creativity component and a bunch of other stuff. And machines are really good at computation, right? And so that's actually one of the fundamental issues with translation is that it's not just a classification task like speech recognition or image recognition. There's some classification task of understanding, what are the words initially, but then there's abstraction layers, there's logic, there's, the part of the creative process that we don't really understand how it happens within a human, right? And so that's kind of the path that we're taking. And so that makes it very different than to give you a sense. For example, I can take a sentence, give it to 5 people, they can all translate it, it can all be correct, and it can be all very different. There's no ground truth to it.
And how much of that is due to idioms?
Some, right? Some definitely. But even within canonical proper.
But I guess everything about language is somewhat idiomatic, even like just more subtle aspects of it.
Definitely. I mean, that's actually one of the reasons why language is so important, is because it is the easiest way to identify who belongs to your tribe, right? And your tribe is defined by the idioms that it has. So, if someone speaks English natively, like, okay, it's probably from the US, and if they speak the same way that you do, then okay, they're in my profession, or they're in my, and then if they have that particular idiom from your neighborhood, it's even closer, right? So the closer their language matches yours, the more they belong to your tribe. And so it's important to have those idioms as a way of distinguish yourself and of identifying yourself with people that are similar. It's an interesting phenomenon with language, right? I mean, you take 50 people, you put it in the middle of the forest, and 50 years later, they have a new language. So there's something inherently, innate to humans of creating new languages. Teenagers do the same, right? They basically start differentiating themselves from adults by creating their own language, their own words.
Yeah, and I should have defined the word idiom in case a listener doesn't know what it is. Idiom is kind of like a slang sort of thing that's like local to your language. Like if you say, like in English, for example, if you said, "Oh, that's off the wall," like that means that's crazy. But that's off the wall would not necessarily translate well from English to, I don't know, Italian. So how does you spend a lot of time in academia, you got your PhD. How does the industry approach to translation differ from the academic approach, or is there indistinguishable?
They're very different, I think. I mean, when you get to Google, for example, they're a little bit indistinguishable because the people in Google doing machine translation, they're not really thinking about it commercially. I mean, there are other people that would be thinking about it commercially within Google, but not the people actually building the system. So they're really thinking about it almost as an academia person of saying, here's a problem, I want to solve it, right? But in most cases, if you look at sort of smaller translation companies, machine translation companies in particular, it's, people will take a lot of shortcuts, a lot of engineering. There's a lot of misuse in general of the word AI and what it means and machine learning. And, everybody has big data and big data now is out of use. But, there's a little bit of a hype going on where everybody has to have everything. And so sometimes I feel that in the translation world, it's like everybody's kind of selling you a Ferrari, and if you're lucky, you'll get a BMW, but then most times you'll get like a Fiat. It's everybody has all the features, they do everything, but it's kind of hard to tell because in the end, since there's so much is dependent on a human, humans are really good at dealing with noise, so they can overcome the lack of certain technologies, for example.
Do you have any perspective, or can you talk about how Unbabel's approach diverges from the Google Translate approach? I guess to model building. Obviously, the human in the loop is fundamentally different. But
definitely, that part is fundamentally different. But even at the level of machine translation, our philosophy is very different. So Google is fundamentally trying to solve the overall machine translation problem, which is amazing, and they've been doing an amazing job. We are really focused on domain-specific machine translation. So we do have a basic general model, but what we do is we take, so now we're focused on customer service, right? And so our model is really good at customer service because you understand, it's really trained with the data that's coming from our customers that are in the customer service world. And so in a way, what we're doing is we're creating hundreds of machine translation engines, each of them adapted in a particular domain. and in those domains, in the ones that we're focused on, we're better than Google Translate. But it's a very different approach.
What I hear you saying is again, the importance of the specific domain that is used to train the language of model, the language model for translation. That's so fascinating that it really matters. If you're doing customer service translation, you are going to bias your translation model to a way of translating that is more generous and welcoming and the things that you would expect from a customer service representative.
Yeah, definitely. I mean, domain is everything, right? I mean, it's and it's also, if you think about it, it's a way of breaking down the problem, right? I mean, the problem is intractable right now. I mean, I don't think we're close to solving machine translation. I think we're still very far away. I think there's fundamental insights that haven't happened yet. I think we'll eventually get there, but I don't think it's going to be next year or the year after. I don't think it's going to be the next 5 years. And so a solution for that is breaking down the problem into smaller parts. And we say, okay, instead of focusing on the whole search space, we're going to say we're going to start by this domain, and that immediately reduces ambiguity significantly. You can have a much bigger coverage. There's less variability. All of those helps. So, I mean, the idea that machine translation with domain adaptation is better than general machine translation, that's been around for a long time. It's kind of a well-known fact, right? It's a more reasonable approach if you don't have billions of dollars and infinite resources.
Every software project uses email. Every time an e-commerce site processes a transaction or a user makes a comment on a social network, email notifications are sent. SparkPost provides email delivery services for apps and websites. To try SparkPost and send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. SparkPost has a range of pricing options, from free self-service packages to sophisticated enterprise support and services. Start sending emails to your users today. Go to pages.sparkpost.com/sedaily to send 100,000 emails a month for free. Thanks to SparkPost for being a new sponsor of Software Engineering Daily. And if you want to send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. I was thinking about how useful translation is in a business context and where you can use translation to save costs or create new profit centers. And I was thinking about this, how companies use Unbabel to translate support tickets. And I can see this as being useful either to translate tickets into a language where someone in a lower income country can read. Like if you have an English support ticket, but you want to translate it to some language of a lower income country, then you can lower the cost of servicing that support ticket. Or you could have the language translated from somewhere that is not English to English, and then you could have very sophisticated support tickets that need to be read by English-speaking engineers rather than hiring the rare engineer that actually speaks that language. And I think there's just so many opportunities for how translation can be used to lower the cost of doing business. Can you elaborate on that? What are some of the great opportunities for companies to use translation to create profit centers or reduce costs?
There's a lot of different use cases, right? I mean, language is so ubiquitous into a company. I mean, think about what would the world GDP be if there were no language barriers? It's phenomenal. So, for example, yesterday we were at a Tech Refugees meeting, which is a project for helping refugees. And systematically, the first thing they said, the biggest issue they had in trying to start a new life in a country is language. They don't understand the language. They can't interact. It's a huge problem. For companies, that actually comes out in a lot of use cases. So customer service is definitely one of them. 75% of the world doesn't speak English. I know sometimes it seems ridiculous, but it's true. And especially the next 3 to 4 billion people that are coming online won't speak English. They're from developing countries. And just because they don't speak English, they shouldn't they still deserve good customer service, right? Right now, if you send a ticket in Portuguese to most companies, they will just reply with English. They just don't care, or they will reply with, sorry, we don't do Portuguese. Most of them or not reply at all. And so it means you're effectively cut off from access to products that a lot of times are worldwide, or information or services, or which in a global society is really hard. But also, so you can optimize a lot. The other is that for a company, hiring people in different countries and maintaining teams in multiple, time zones adds a lot of complexity. Then there's a lot of turnover in customer service. Finding continuously people that speak German is hard. And so and then if you want to do 24/7 customer support in a language, you need 4 people that speak that language, and then people take vacations and there's weekends. And so this means that anybody can respond to those tickets, which is a big difference. We also recently integrated with Facebook Messenger, and we did chat, which has been really fascinating to see the use cases on that. But then if you move to profit centers and value creation centers, you can think of a number of things. So you want to run your marketing campaigns in multiple languages. You already created the content in English. Why not use that globally? Or you want to run your ad campaigns. How do you do that, right? You create, typically right now, ad keywords in English are much more expensive than in other languages. You could just, run your campaigns in multiple languages and improve the value that you get for them significantly. Or you could do, obviously, website or internal company communication. Or you can do, if you're producing videos, right now there's a ton of videos online. Nobody turns the volume on, right? I mean, you see it on your Facebook and they're always volume off. If you don't have subtitles, basically people don't see them. And if you need subtitles in multiple languages, if you're going to attack other markets, and even more, if you don't right now, what's going on in YouTube, if you search for a video of some musician, right, and then you search for the same video and you just add some language like Chinese, you'll find another video that has subtitles in Chinese, which means that if you don't have subtitles, in a bunch of languages in your videos, somebody will take your video, add subtitles, and they're going to get all the clicks of people that don't speak English, So you're actually losing a lot of potential and for content that you already spent creating. So there's a lot of use cases inside a company.
Microsoft has been working on speech translation for a long time. They recently came out with some what they called big breakthroughs. I haven't had time to look at this literature, but they said these were big breakthroughs. I know they're also working on putting translation into Skype and other products to have on-the-fly audio translation, which is, of course, the epic future that we are all thinking about. Have you looked at what Microsoft has been doing recently, or have you gotten a chance to mess around with the Skype translation product? Do you have any perspective on how the user experience is?
Oh yes, very much, because they're our customers, and we collaborate with them on it. So I can't really discuss very much what we're doing with them, but we're very aware of what's going on. Yeah.
Okay, so those breakthroughs that they're talking about are legit.
Yeah, there's been an incredible advance in speech recognition, right? Deep learning had a huge impact because
it's deep learning, right?
Yeah, exactly. That was one of the areas. So first was image recognition and speech recognition, because fundamentally speech recognition is a classification problem and of a continuous input, which is perfect for deep learning, right? And so that had a significant impact. The translation part is still the hard part.
What kind of lever is deep learning giving us for these problems that are ultimately classification problems for which we have lots of data for? Because the classic estimation for this type of growth is exponential growth based on Moore's law. But to me, it seems like we've become almost decoupled from the ideas of Moore's law, because this is totally distributed computation. We're not talking about a specific processor. It seems like the growth is directly related to how much data we have and how fast we can pipe that data into our machines. Do you have a handle on how fast these kinds of fields are moving?
A little bit, so I think that we haven't seen it plateau yet. I think we're going to have 2 or 3 more years of just pure continuous advance on the stuff that's coming out with deep learning. I think a lot of the work now is on like attention models within deep learnings, which is trying to figure out, how do you actually help within a deep learning model, how to make it more efficient, how to understand which parts is using more than others, so making less like a black box. The other is really on the amount of abstraction layers inside, right? So if you think about it, a deep learning model right now requires 100 more or a million times more data than a baby needs to get to a result that is much less efficient, right? So clearly, it's not just about the data; it's really a lot about the structures that we're using for neural nets that aren't really nearly as efficient or as big as a human, right? And so they don't.
Although
go ahead.
For the baby example though, a baby is taking in sensory input from 5 different axes,
Yep.
and a machine if you're doing just text translation, that's a single axis of learning.
That's true. But even with children that have experiments where they're sense deprived, like deaf and deaf is harder, but like blind kids and kids with disabilities, the learning rates are much higher, right? So I think the structure of our brain is still much more complex than what we have right now. So I think data will take us a little bit further, and it really depends on the task. So some tasks, like I said, classification tasks, I think we're getting really good at it. I think the part that we haven't quite figured out, for example, so simple things like in translation, how do we use glossaries within neural nets? So you have words that you say, okay, I know that this word, I want it to be translated this way, and no one's figured a good way of building that in within training the model. How do I, like it's a lot of one specific things. The other is there's a point in which more data doesn't help you, right? So right now there's already a lot of translation data. I mean, more translation data that you should ever need to be able to learn. If you had, I think that's really what's missing, the right structure, abstraction, something that we don't understand what it is yet. But so I don't think that it will take us exponentially to the point where it's solved. I think it will continue to improve, and then it will plateau at some point unless the insights keep happening. At the same time, there are around the world hundreds of people working on this, and more importantly, which I think is fascinating with deep learning, is that it's actually simpler, right? So it used to be that a lot of the stuff you did during a PhD, if you did work on machine learning, was thinking about features and feature creation. And now with deep learning, a lot of that has been basically the neural net actually creates the features by themselves. The side effect of this, instead of needing someone that has years of practice and maybe a team to create a model, you can now have a PhD student in a month create a significantly usable model for a real world problem, which we already had here, right? So, which means that, there's going to be way more people working on these problems, which means that, the likelihood of having insights is bigger and bigger. Yeah. I think in a way, deep learning does bring also a little bit of a democratization of AI, which I think is really important.
Right. Okay. Last question. I think you're 32 or so. You're about my age, I think, or 33.
I'm 40.
Older?
Thank you. Yeah.
You're 40. Okay.
Yeah.
Wow. Okay. You got some old pictures on your material, or maybe you just look remarkably young.
People usually tell me that I look young, but thank you.
Okay. Do you think that in our lifetime we will have the device that we can just put in our ear that will translate anything anybody says to us?
Yeah, I think so. I mean, I'm planning to live forever anyway, so yeah, by definition we will.
Okay. All right. So 20, 30 years?
Yeah. The estimation, the best people's estimation is that singularity will happen in 25 years. I think it won't happen before then. I think that's kind of the breakthrough that we need to actually have something really translate is almost at the level of singularity.
Right.
I think you need to have experience in the world to really be able to really translate something and understand the cultural nuances and understand what's the best way to say it to this audience and so on. And I think we're talking about 20 years to get to that point, to especially with a device that anybody can speak, and you understand there's multiple speakers and you can distinguish between background noise, and because speech recognition, it works really well if you have like a closed set mic in one person right now. It's really, really amazing. But if you have it in a microphone in an open room with 5 people talking, forget it, right? It goes crazy.
Okay, Vasco, this was a great conversation. I want to thank you for coming on Software Engineering Daily.
Thank you very much. It was a pleasure.
Software Engineering Radio is the podcast where I learned how to make high-quality content. I have been a part-time host on SE Radio for 4 years, and it has been a fantastic learning experience and community. SE Radio is currently looking for volunteer hosts, and if you're interested in learning how to podcast about software engineering, contact Robert Blumen, the editor of Software Engineering Radio. His email is robert@robertblumen.com, BLUMEN. On that note, Software Engineering Daily is also looking for new hosts, and you can email me, jeff@softwareengineeringdaily.com, if you are interested. Podcasting about software engineering is a great way to build a stronger understanding of technical topics, whether you are early in your career or later on in your career. If you're interested in Software Engineering Radio, I encourage you to email robert@robertblumen.com to learn about Software Engineering Radio. And if you're interested in Software Engineering Daily, email me, jeff@softwareengineeringdaily.com. Thanks for listening.